Hello, my dear students. Welcome to my channel Physics by MKR. So, in the previous video, we discussed about the resolution of vector into components. Now, in this video, we are going to discuss about the types of vectors. When you compare different vectors, we have different names to mention them. But already discussed about a special vector called unit vector whose magnitude is 1 and the direction is in the direction of its original vector. And the modulus of I bar is equal to modulus of j bar is equal to modulus of k bar is equal to 1. And there is a special vector called null vector whose magnitude is 0 and the direction is arbitrary. Arbitrary means we can attribute the direction in any way. For example, if you subtract a bar from a bar, that means the difference of two identical vectors is also a vector which is called null vector. In this way, we have so many null vectors and we will discuss them in later. And when you compare two vectors A bar and B bar, with respect to their directions, if the angle between them is 0, they are called parallel or like vectors. And another symptom of parallel vectors is the ratio of their components, respective components. For example, if you take A bar, it is AXI plus AYJ plus AZK, and B bar is BXI plus BYJ plus BZK. And the X components ratio, AX by BX, is equal to Y components ratio, AY by BY, is equal to Z components ratio, AZ by BZ. So the ratio of the components is a constant and is also positive. If these two vectors, which are parallel to each other, have same magnitude, they are called identical vectors. That means the magnitudes are same, directions are same, so they are all identical in all respects. That's why the constant c becomes plus 1. And if the angle between the vectors is 180 degree, they are called anti-parallel or unlike vectors. And the ratio of the components is negative and is equal to some constant. And if the magnitudes of these anti-parallel vectors are same, they are called negative vectors of each other. That is, A bar and B bar are opposite and with equal magnitude, and that is A bar is equal to minus B bar, and sum of two negative vectors is a null vector. Next, normal vectors. If the vectors are mutually perpendicular, they are called normal vectors. And vectors of same magnitude. That means the magnitudes of the two vectors A and B are same, but their directions are different. Then we call them as vectors of same magnitude. And another important classification is polar vectors and pseudo vectors. Polar vectors are also called as real vectors because their direction is permanent with respect to any coordinate system. It does not change with the change of coordinate system. Whereas the directions of pseudo vectors are purely imaginary, are attributed, and their direction gets reversed when coordinate system is shifted from right hand to left hand system. For example, if you consider velocity and acceleration, a body is moving towards east with some velocity, say 10 meters per second, and that remains same whether you measure it from right hand coordinate system or left hand coordinate system. Whereas if you take a circular motion in anti-clockwise direction, that circular motion is associated with different quantities like angular velocity, angular momentum, torque, etc. And those quantities will have conventionally their directions along the axis in the upward direction if the circular motion is anti-clockwise. When you observe this same circular motion, which is anti-clockwise, with respect to right-hand system, when it is observed from left-hand system, it appears in clockwise direction. Thereby, the direction of these axial vectors, angular velocity, angular momentum, and torque, they will be downward. That means their direction gets reversed under the inversion of coordinate system. That's why they are called pseudo. Because their directions are along the axis, they are also called axial vectors. Some physical quantities having both magnitude and direction are not vectors, they are scalars because they do not follow vector addition rule. For example, you take strength of electric current. Suppose there are two branches of electric circuit, and in those two branches, I1 current, say for example 2 ampere, and I2 current 3 ampere are entering in this junction and they combine as 5 ampere. But it is having magnitude and direction as represented by arrows. But this electric current is not following vector addition rule, that is parallelogram law. According to parallelogram law of addition, this I must be equal to I root over I1 square plus I2 square plus 2 I1 I2 cos 60 if current is a vector. But this is simply scalar addition. 2 plus 3 is equal to 5 ampere. It's not having the magnitude given by this formula. So because of that, it is a scalar quantity. So whenever a doubt arises, you can check whether it is a vector or scalar. If that quantity possesses both magnitude and direction, then if you apply parallelogram law, if it satisfies that equation, then we can confirm it as a vector. Otherwise, it is a scalar. And another important quantity is area. Area is generally a scalar quantity, but sometimes it attains vector nature if that area contains electric field or magnetic field. Then we call that area as areal vector. So when you call it as areal vector, it must have some direction. And that direction is normally away from the area. Suppose if this is the area in which the electric field or magnetic field is there, and the areal vector is taken as along the normal away from the area. So these are some of the misleading quantities about vectors. And regarding the properties of vector, if a vector is shifted parallel to itself, either in the forward direction, or in the backward direction, or in the upward direction, or in the downward direction, or in any direction parallel to itself, the vector does not change, it remains as it is. But if a vector is rotated about its tail through some angle, then that vector changes. Why? Because vector possesses magnitude and direction. Now the magnitude of this vector is not going to change because the length of the vector is remaining same. But the only thing is its direction changes. So either magnitude changes or direction changes, or if both change, we say that vector changes. Now, for example, this A bar makes angle 30 degrees with x-axis in the initial condition. Now, I can represent that A bar as A cos 30 I plus A sin 30 j. If that vector is rotated through 15 degrees, now the angle becomes 30 plus 15, 45. The magnitude of this vector b bar is same as that of a bar. That is why I can represent this b bar as a cos 60 I cap plus a sin 60 j cap. That means what will happen when a vector is rotated about its time means the vector changes. Along with the vector, their rectangular components also change. But only thing that remains constant is magnitude. Suppose if the frame of reference is rotated without any change in the vector position, then the vector remains same, but its rectangular components again changes because the angle made by the vector with the new axis will change. So these are the some of the effects when a vector is rotated and frame of reference is rotated. These are the things which we have to understand. Thank you for watching my videos and giving support.